Hello everyone, welcome back to my channel Gemsofknowledge. So today we are going to solve the continuation part of this exercise, that is 2.2 of triangles chapter, that is from class 10. So before starting my video, make sure to subscribe to my channel and also click on the bell button to get the notification as soon as I post my new video. So I hope you have seen the first two questions which was posted in the last video. So if you have not watched it, I'll link it into the description box. You can check it out. So here you can see the third question which is given in figure 2.18. So this is the figure which is present in your textbook on 2.18. Okay, if LM is parallel to CB, so this LM, as you can see here, this is parallel to this CB. Okay, and LN, this part is parallel to this CD. So we need to prove that AM divided by AB, okay, this part AM divided by this AB is equals to AN divided by this AD. We need to prove this. So let us write what is given. Okay, so given terms are LM is parallel to CB and LN is parallel to CD. Okay, this is the terms which are given, as you can see here. Okay, so what we need to prove? This is given. Now we need to prove AM by AB is equal to AN by AD. This is what we need to prove. So let us start with the proof. So we will consider this triangle first, that is ACB. Okay, ACB or ABC you can say. Okay, so in triangle ABC, okay, we know that LM is parallel to CB already, which is given here into the question. So in this upper part triangle, we know that LM is parallel to this BC or CB. Okay, so according to your BPT theorem, we will get AM divided by AB. Okay, so if we consider this this triangle to be like this, then we will get this AM divided by MB or AB. Okay, so since here they are asking us AM divided by AB, the complete triangle they are asking, so we will take AM divided by MB is equal to AL divided by AC. Okay, we will take this as equation 1 since by BPT theorem. Okay, since basic proportionality theorem. So if these two parts are parallel, if these two lines are parallel to each other, then this AM is divided by AB and AL is divided by AC. Okay, this is equation 1. Now let us consider the second part of the triangle, that is in triangle ADC. Okay, as you can see ADC, we are having LN parallel to CD. Okay, this LN is parallel to this CD. So what we will consider? We will consider AN divided by AD is equals to AL divided by AC again. This is equation 2. Okay, so this AN divided by ND or DN and which is equal to AL divided by LC. This is equation 2 since again by BPT. Okay, now let us consider the two equation, that is from equation 1 and 2. From equation 1 and 2, as you can see, AL divided by AC here also and here also it is AL divided by AC. So if this both are equal, then we can equate this. Okay, that is AM by AB is equals to AN by AD. This is what we needed here. You can see AM divided by AB is equals to AN divided by AD. Okay, so this is solved. Okay, let us now move on to the fourth question, that is next question. In figure 2.19, so this is the figure which was present on 2.19. So DE is parallel to AC. Okay, so here DE, this line is parallel to AC. First of all, they have given DE is parallel to AC and this DF is parallel to this line AE. What we need to prove here is BF divided by FE is equals to BE divided by EC. Okay, so this part divided by this part is equal to this part divided by this. We need to prove. Okay, so let us first write what is given. So given here is DE is parallel to AC and DF is parallel to AE. Two things are given. So to prove, what we need to prove here is BF divided by FE is equals to BE divided by EC. Sorry, EC. Okay, this is what we need to prove. So let us take proof. So we'll first consider this one. Okay, this triangle, the whole triangle, that is in triangle ABC. In triangle ABC. So in triangle ABC, we are having AC is parallel to what? As you can see, this AC is parallel to this DE. Okay, so we'll take DE is parallel to this AC. Then according to BPT, we can write that BD divided by AD. You can see this BD divided by this AD, or DA, one and the same, is equal to this BE divided by this EC. Okay, so since we are taking this line, as you can see, we are taking this line, so it means this is the half part and this is the half part. Here also this is the half part and this is the half part. So this part we have taken, that is BD divided by AD or DA, one and the same, and this part, this line is passing here, so this part, that is BE divided by EC. BE divided by EC, equation 1 since BPT. Okay, then similarly in triangle, next triangle, what we have to take, as you can see, DF is parallel to AE. Okay, so DF is parallel to AE, so we need to take this AE part, means we only have to take ABE part. Okay, so we will consider the triangle ABE. Okay, in which we are having DF is parallel to AE. Okay, so here what happens, BD divided by AD, again this part will be the same. Okay, this part will be the same, only here the partition will be changed, since we are taking only this much triangle, this part. Okay, so BF divided by FE it will be, so which is equals to BF divided by FE. This is equation 2, again since BPT. So as you can see from both the cases, so as you can see from equation 1 and 2, you can write, here you can see BD by AD, here also you will get BD by AD. So both are equal to BE by EC is equals to BF by FE. So we can write BE by EC, which is equals to BF by FE. Okay, this is what they are asking us. BF by FE is equals to BE by EC. Okay. Okay, so we'll move on to the next one, that is fifth question. In figure 2.20, this is the figure which is 2.20. DE is parallel to OQ. So here you can see DE is given, okay, which is that, okay, here. DE is parallel to this OQ and this DF is parallel to this OR. So what we need to show, this EF is parallel to this QR we need to show. Okay, so what we will do is, we will consider this triangle first, that is POQ. Okay, we'll consider this triangle. So first let us write solution. Given, what all things are given here? DE is parallel to OQ and DF is parallel to OR. This is what they have given. Okay, then to prove, what we need to prove here is this EF is parallel to QR we need to prove. So let us take the proof. Okay, so in triangle, what is this triangle we will take? That is OPQ. Okay, OPQ. In this triangle, they have already given us in OPQ what is parallel. This DE is parallel to this OQ. Okay, DE is parallel to this OQ. If this DE is parallel to this OQ, then we can write PE by EQ. PE by EQ is equals to this PD by OD. This is equation 1 since BPT. Similarly, we'll consider this part of the triangle. Now, in triangle OPR, we know that DF is parallel to OR. Okay, here they have given DF is parallel to OR. Then we can write PD by OD. PD by OD is equal to PF by FR. This is equation 2 since BPT. This is also BPT. Okay. Now from equation 1 and 2, as you can see, PD by OD is equals to PE by EQ. Okay, here also PD by OD is given, here also PD by OD is given. So we can equate this both, that is PE by EQ is equals to PF by FR. So as you can see, what they have given, PE by EQ, okay, this part we got, which is equals to PF by FR. So we got this complete triangle here. So if we got this complete triangle, what is the line which is crossing here? Okay, so what are the two lines which is dividing this to this triangle? That is EF by QR. So therefore EF will be parallel to QR. So this part is according to the converse of the basic proportionality theorem. So I hope you remember the converse here, that is BPT converse. Okay, so where it says if these two parts are equal, then the line which is passing through the center of the triangle will divide it into the two ratio, okay, will be parallel. So EF is parallel to this QR. Okay, now moving to the sixth question, that is in figure 2.21. Okay, so this is the figure which is shown as 2.21. Okay, and here they have given A, B and C. These are the points on OP, OQ and OR, okay, respectively, such that AB is parallel to, they have already given this AB is parallel to PQ, okay, this AC, this line is parallel to this PR, and we need to show that this BC is parallel to this line QR. Okay, so let us first write what is given to us. That is given AB is parallel to PQ and AC is parallel to PR. They have already given. And one more thing they have given, that is A, B and C are points on OP, OQ and OR. Okay, this is given. Now what we need to prove? We need to prove that BC is parallel to QR. This is what we need to prove. Okay, so let us consider this triangle first, that is OPQ. Okay, so proof triangle OPQ. Okay, in triangle OPQ, they have already given us that AB is parallel to PQ. Okay, AB is parallel to PQ, already they have given. So if we consider this triangle, so what we will get, OA by AP. So what we will get here, OP by AP is equals to OB by BQ. Okay, so here we got OA by AP is equals to OB by OQ. Okay, now we will consider this triangle, that is POR. Okay, so triangle POR, in this we are having that AC is parallel to PR. We are having AC is parallel to PR. AC is parallel to PR. So here we will keep this as equation 1. So here we will get OA by AP again. OA by AP, which is equals to OC by CR. OC by CR. So this we will consider as equation 2. Okay, so if this is equation, here you can write the same reason, that is by BPT, and here also the same reason, that is since by BPT. Okay, so here you can see you got the same thing, that is OA by AP, here also OA by AP, which is equals to OB by BQ, which is equals to OC by CR. So since you got two things here similar, so you can equate this two. So from equation 1 and 2, you can write it as OB by BQ is equals to OC by CR. You got, okay. So if OB, you can see here OB by BQ, which is equals to OC by CR, if you got, then by this triangle, okay, then by triangle OQR, you can mention that BC is parallel to QR. Okay, this is by the theorem, second theorem, that is converse of BPT. Since converse of BPT. Okay. So you can see the next question, that is seventh one. Using theorem 2.1, that is BPT theorem. 2.1 in the sense that is BPT theorem. Using BPT theorem, prove that a line drawn through the midpoint of one side of the triangle parallel to another side bisect the third side. This is the question, and in the hint they have given us, recall that you have proved it in class 9th. Okay, so a rough diagram which I have drawn. Okay, so there is no diagram in the question. This is the rough diagram which I have drawn, where ABC is a triangle. Okay, so what they have told that, prove that we need to prove a line drawn to the midpoint of one side. So we will consider this is one side AB, and the midpoint of this AB is P. Okay, midpoint of one side of the triangle is parallel to another side. Okay, which is parallel to another side. So this line is parallel to another side. This is the second side of the triangle. This line PQ is parallel to another side. Okay, so for the first side, this P is the midpoint. Okay, and for the second side, this is parallel, that is for BC, this PQ is parallel. Okay, and we need to prove that it is bisecting the third side, means it is also dividing the third side into two equal part. We need to show this. Okay, so we will write solution. Given, we will write again the same thing. Given, what is given? P is the midpoint. Okay, P is the midpoint of AB. Okay, this is what they have given us. P is the midpoint of AB and PQ is parallel to BC. Okay, this is also given. See, as you can see, through the midpoint of one side of the triangle is parallel to another side, means this PQ is parallel to BC, and PQ is parallel to BC. This is what they have already given. What we need to prove here is to prove Q bisects, or we can say Q is the midpoint of AC, or else we can write Q is bisecting this AC into two equal part, or else we can write this, or Q is the midpoint of AC. We need to prove this. Okay, so let us write the proof. As you can see, we need to consider the triangle here, that is ABC. Consider the triangle ABC, wherein we know that AP is equals to, sorry, not equals to, AP, this AP divided by PB is equals to AQ divided by QC. Why? Since BPT. They have already told us to use the theorem 2.1, which is BPT. Okay, so we are having this according to BPT. We are having AP by PB is equals to AQ by QC. Okay, this is according to BPT. Okay, now we know that this AP, since P is the midpoint of AB, we will get AP is equals to PB. We will get AP is equals to PB. Since this is the midpoint, it means this and this part are equally divided. Okay, if it is the midpoint, if this is 4 centimeter, then this P is dividing this two part into 2 centimeter and 2 centimeter each. Okay, so we can write, in place of this AP, we can write it as PB. So this equation 1, we'll consider this as equation 1. So this equation 1 changes from, in place of AP, I will write this as PB by PB, which is equals to AQ by AC. Okay, so it implies that PB and PB is cancelled. We will get 1 is equals to AQ by AC. Okay, so if we again cross multiply, this 1 is multiplied by this AC, we will get AC is equals to AQ. Okay, so we'll get AC is equals to AQ. Just see, AC, sorry, I made a mistake here. This is not AC, this is QC. Okay, as you can see here, AQ divided by QC. Okay, this is QC. Here it is QC. QC is equals to AQ. Okay, this QC is equals to this AQ. It means if this QC is equal to this AC, it means this. It means Q divides AC. Therefore, Q is the midpoint of AC. Okay. Okay, so next question you can see, eighth one, using theorem 2.2. 2.2 is nothing but the BPT, converse of BPT theorem. Okay, so using that converse theorem, we need to prove that the line joining the midpoint of any two sides of the triangle. So these are the midpoints of two sides of the triangle. So these are the two midpoints of the triangle, that is P and Q are the two midpoints of the triangle, and we need to prove that this PQ, two midpoints of the triangles, are parallel to the third side. Okay, so it means we need to show that PQ is parallel to BC. Okay, so let us solve. Already given terms are P is the midpoint of AB and Q is the midpoint of AC. Okay, these are the terms which is given. Okay, so we need to prove that, to prove PQ is parallel to BC, we need to prove that this PQ is parallel to this BC. We need to prove it. Okay, so as in the proof we can take, the proof, since P is the midpoint, since P is the midpoint of AB, since this P is the midpoint of this AB, we can write that AP is equals to PB. This is equation 1 we will keep. Similarly, since Q is the midpoint of AC, we can also write AQ is equals to QC. We will keep this as equation 2. Now we know that according to the converse of BPT, we know that AP by PB is equals to, we can write the BPT as AP by PB is equals to AQ by QC. Okay, so we can write according to, since BPT we can write. Okay, so I made a mistake here also, is as you can see, this must be AP by PB. Okay, so this was AP by PB, so this is AP by PB, which is equals to AQ by QC we are having. Okay, so now in place of AP I can write it as PB. So PB divided by PB is equals to, in place of AQ I can write it as QC. So QC divided by QC, if I write, so this and this is cancelled here and here this is cancelled, so we are getting 1 equals to 1, which shows that this and this are according to BPT, it is correct. Okay, so if this is according to BPT, if these parts are in ratio, therefore we can write AP and, so we can write AP by PB is equal to, okay, is equal to AQ by QC. Okay, then we can write PQ is parallel to BC since converse of BPT. Okay, now moving to the next question. As you can see here, ninth one, ABCD is a trapezium in which AB is parallel to DC and its diagonals intersect each other at a point O. Then we need to show that AO by BO is equals to CO by DO. So a rough diagram of a trapezium is drawn here. I have drawn here. Okay, so they have only given us the question. There is no trapezium diagram in the figure, in the textbook. Okay, figure is not there in the textbook, so I have roughly drawn it. ABCD is a trapezium. So A, B, C and D is our trapezium. Okay, in which they have already given that AB is parallel to DC. Obviously, if it is a trapezium, then AB will be parallel to this DC. Okay, and its diagonal intersect each other at a point O. So these are the diagonals which are intersecting each other at a point O. Okay, then we need to show that AO by this BO, okay, is equal to this CO divided by this DO. Okay, so for that what I have done is, I have done one small construction, that EF I have drawn, which is again parallel to this line DC as well as this line AB. Okay, so let me write here what is given. Given, they have given is ABCD is a trapezium, intersecting, and they have also given AB is parallel to DC and diagonals intersect at intersect at O. Okay, they have given. To prove, we need to prove that AO by BO is equals to CO by DO. This is what we need to prove. So proof we will write. Okay, so in this proof, before this proof, we need to construct one thing, that let EF be parallel to AB and EF is parallel to CD. Okay, let us consider that EF is parallel to AB and also parallel to CD. Okay, so now we will consider this triangle, that is ADC. In triangle ADC, what we will get, EO is parallel to DC. EO is parallel to DC. Then we get AE, this part, AE by ED, AE by ED, which is equals to this AO by OC. We'll keep this as equation 1 since you know this is BPT. Okay. Now we will consider this triangle, that is AB and D, this part. Since we have taken this triangle, now we will take this triangle. This triangle is turned out, okay, like this. So in triangle ABD now, this part. Okay, again EO is parallel to, here EO was parallel to DC. Now this EO is parallel to AB. Then we get this triangle is turned out, okay, like this. Okay, so this DE by EA, this will be DE by EA or AE is equals to DO by OB. Equation 2. Okay, now if this equation is interchange, okay, so as you can see, equation 1 is AE by ED. So AE by ED, okay, so this AE, if we change this, this will be AE by ED is equals to, if we reverse this up and down, what we are going to get, OB by DO. Equation 3. Now from equation 1 and 3, from equation 1 and 3, we get, as you can see, AE by ED, here also AE by ED, we are getting AO divided by OC is equals to OB divided by DO. That is AO by OC and BO divided by DO. Okay, since this all are equal, we will get, okay, so since you got this, so you can write, which implies this AO by OB is equals to this OC by OD. Okay, since you can write about these two triangles, that is AO divided by OC and OB divided by DC. So you can also write AO is equal to this OB, that is they are in ratio, and it is equals to OC divided by OD. Okay, so now you can see the last question of this exercise, that is the diagonals of the quadrilateral ABCD. So here a figure is roughly drawn by me itself. Okay, so the quadrilateral they have given, ABCD is a quadrilateral and the diagonals of the quadrilateral are intersecting each other at a point O again. Okay, such that AO divided by BO is equals to this CO divided by this DO. So what we need to show here is ABCD is a trapezium. We need to show that ABCD is a trapezium. Okay, so let us write what we need first. Solution, what is given? Diagonals of quadrilateral ABCD intersect at O. Okay, and they have also told us that AO by BO is equals to CO by DO. What we need to prove? To prove ABCD is a trapezium. Already they have given us it is a quadrilateral. We just need to show that in the quadrilateral it is a trapezium. Okay, now next, proof. This is what we have proved in the 9th one. Same thing we need to repeat here, but in the reverse manner. Okay, so we all know that AO by BO is equals to CO by DO, already given. Proof. AO by BO is equals to CO by DO. That is AO by BO is equals to CO by DO. It is already given. Okay. So as you can see, AO by BO is equals to OC by DO. This is what given here. Okay. So in the reverse manner, if we go, we are having AO by OC is equals to OB by DO. So we'll consider this, which implies AO by OC is equals to OB by OD. We'll consider this as equation 1. Okay. Next, one more thing we will consider, that is, we will consider this triangle, that is A, B and D. Okay, we will consider this triangle. So in triangle ABD, what we are having in triangle ABD, if EO is parallel to AB, EO is parallel to AB. So EO is a line which is drawn here, which is parallel to AB. If we consider this triangle, then this EO is parallel to this AB. Then we will get AE by ED is equals to OB by DO. We'll get equation 2. Okay. So we got here AB by OD. Here also we got AB by OD. So we can write from equation 1 and 2. From 1 and 2 we got AO by OC is equals to AE by ED. We got. Okay. So AO, you can see AO by OC. Okay. This is AO by OC, which is again equal to AE by ED. What we got? We got this triangle. That is we got, okay, we'll write here itself. It means we got triangle ADC. So in triangle ADC, we can write EO is parallel to DC. Since these are equal, we can write EO is parallel to DC, since converse of BPT. Okay, since it is converse of BPT. So EO is parallel to DC we wrote, but here we wrote EO is parallel to AB. Here we are writing EO is parallel to DC. So we can write EO is parallel to DC, and again this EO is parallel to AB also. So in the proper manner, we can write AB is parallel to CD or DC. So instead of showing that EO is parallel to DC and EO is parallel to AB, we can write AB is parallel to DC. Okay. So if this AB is parallel to this DC, we can also mention that ABCD is a trapezium. Okay, so this is cleared here. So I hope you have understood with the whole exercise here. If you are having any doubts regarding this, you can comment me down below. So I'll be back with next exercise in my next video. So till then, stay tuned and stay connected. Don't forget to like, share and subscribe. Thank you.